So we have 3.2.4. So the focus for today is going to be on finding x-intercepts, or roots, zeros, solutions, all words we've heard before, especially from last unit. Before we start with our new learning target, let's revisit some of the old. So this is learning target 3.2.1. That's what we have here, adding, subtracting, and multiplying polynomials. So pause the video, give those a try on your own. Okay, we're back. Remember, when we're adding or subtracting, the key idea is just combining those like terms. So when we're adding, we don't have to worry about changing signs or anything. So we look for the highest exponent or highest degree. That would be this one here. So that gives us 8x squared. We don't have any other x squared terms, so can't combine that with anything. We move down. So we have two x terms, so 4 plus 9 is 13, so we get 13x. We have two constants, 2 and 3. 2 plus 3 is 5. Okay. For b, when we're subtracting, this is where we like to take that extra step and distribute that negative so that we don't forget that subtraction's there. So we're doing -1 times -8, -1 times 9, -1 times 3. So now we can just combine things as they are, not worry about that subtraction in the middle. So again, look for the highest exponent first. So that's this x squared. Don't have any other x squared terms, so we just write that there. Then move on to our next. We have two x terms. 4x minus 9x gives me -5. 4 minus 5 is 4 minus 9 is -5. And then 2 minus 3 is -1. Last one we have is multiplication. When we're multiplying, remember every single thing from the every term from the first set by every term from the second. So I'll take my 4x, multiply that by 8x. 4 times 8 is 32. X times x squared is x to the third. Remember, add the exponents when you're multiplying variables. So 1 and 2. Next, 4 times 9 is 36. X times x is x squared. Then 4 times 3 is 12. And then we just have that singular x. Moving on to 2. 2 times 8 is 16. And we've got that x squared. 2 times 9 is 18. We've got that x. And then 2 times 3 is 6. From there, combine like terms. So my highest exponent is this 3. Don't have any other x to this third term, so I know we're good there. Then we have x squared. We have 36x squared and 16x squared. 36 plus 16 is 52. We have 12x and 18x. Those add to 30x, and then just our 6 on the end. And there we go. All right, so part of this process of being able to find our roots for polynomials is being able to factor out the GCF. The GCF. So remember, GCF stands for greatest common factor. And essentially what we're doing here is we're looking for, well, what's the largest number or largest variable I can take out of every single term. So as we're looking at number 1, we have 5x to the 4th plus y squared plus 25x squared y cubed minus 20x to the 5th y to the 9th. So let's just start with our numbers. So I have 5, 25, and -20. So I want to think, what's the highest number I can divide all of those by and still get a whole number? In this case, it'd be 5. So that's where we're going to start. Our GCF for our numbers is going to be 5. Next, we move on to the variables. This question still applies. What's the highest number of variables I can divide out of each of these? And the way that we do that is, well, we have x to the 4th, we have x squared, and x to the 5th. So the way that we determine the highest number of that variable we can take out is we look for the lowest exponent. So, for example, like we have x to the 4th here, which essentially means, remember, x to the 4th basically just means x times x times x times x. You have 4 x's. So if I want to take x to the 4th as my GCF, that means there would have to be 4 x's as a part of every term. That's not the case. So if we just look to the lowest exponent, which is 2, that means we can take 2 x's from each of these. And we'll talk about what that remaining polynomial is, but the key idea here is you take the lowest exponent. So the same idea applies for y's. We have y squared, y to the third, y to the ninth. So our lowest exponent would be y squared. Now, what we need to do next is write the remaining polynomial. So this is what we call this piece here. This is our GCF. Our remaining polynomial is what's left over, and the way we determine that is by dividing every term by our GCF. And we just go piece by piece. So we'll start with 5x to the fourth y squared. So 5 divided by 5, well, that's 1. X to the fourth divided by x squared. Well, let's think about what that means. So when we're multiplying variables, remember we add the exponents, like we did up here. If we're dividing, we just subtract. So 4 minus 2, well, that's 2, so that leaves me with x squared. For my y's, y squared divided by y squared, 2 minus 2 is 0, so we have y to the power of 0, which is just 1. So we just have x squared, so we move on to the next. 25 divided by 5, well, that's 5. X squared divided by x squared, that cancels out to just 1, so we don't write anything there. Y cubed divided by y squared, again, subtract the exponents. 3 minus 2 is 1, so I just have y to the first, or just y. Next, negative 20 divided by 5 is negative 4. X to the fifth divided by x squared, again, subtract the exponents. 5 minus 2 is 3. 9 minus 2 is 7, so just subtracting the exponents for the y's. So this piece here, this is our remaining polynomial, okay? So we have a few more to consider here to go ahead and factor out those GCFs. So that's what we'll do. We'll do a couple more together, then I'll let you try 3 on your own. So we'll shift to numbers 2 and 3. So we start with our numbers. So I've got 2, 18, and 16. So I think, what's the highest number I can divide all those by? Well, 2. And then I move to my variables. So I have a to the fourth, a to the fourth. So there's an a in all of them, so I know an a is going to be part of my GCF. I just take the lowest exponent, which in this case would just be the 1, so just a. We have b's in all of them, so I take the lowest exponent, which would be 5, so b to the fifth. So that's going to be my GCF. Next, I determine my remaining polynomial by dividing each term by my GCF. So this is called, again, this process is called factoring out the GCF. So 2 divided by 2 is 1. A divided by a cancels to 1. B to the fifth divided by b to the fifth again cancels to 1, so we're just left with 1 there. 18 divided by 2 is 9. A to the fourth divided by a to the third, so again, subtract those exponents. 4 minus 1 is 3, so I have a to the third. 7 minus 5 is 2, so I have b squared. 16 divided by 2 is 8. 4 minus 1 is 3, so again, subtract those exponents. B to the 10th divided by b to the fifth, so 10 minus 5 is 5. And there we have our GCF. Okay, last one we'll do together. So we look at our numbers, 7, 21, and 10. So we think, what's the highest number I can divide all of those by? Well, it's just 1. So we don't really need to include a number in our GCF. You could write a 1 if you wanted to, but we don't need it. So let's move on to our variables. So we have c to the fifth, c to the sixth, and c to the 13th. Because there's a c in all 3, we can make it a part of our GCF. We just take the lowest exponent, which is 5. So c to the fifth is going to be part of my GCF. And then I move to d squared, d to the third, d to the 12th. Lowest exponent is this 2. So that 2 is a part of my GCF. We continue. So now let's figure out our remaining polynomial. So 7 divided by, well, it's just a 1 basically, so we just keep that 7. C to the fifth divided by c to the fifth cancels. D squared divided by d squared cancels as well. It's our lowest exponent. So then we have 21. 6 minus 5 is 1, so I just have c. 3 minus 2 is 1, so I just have d. Minus 10. 12 minus 2 is 10, so I have d to the 10th. 13 minus 5 is 8, so I have c to the 8th. So you may have noticed For our first two, it goes C, then D. Our last one goes D, then C. That's okay, it's just order. It doesn't technically matter. Usually, though, we do want to write it in the same order for all terms. So write this as C, then D instead. So the preference would have been to write that on the end there, like so. Okay. All right, so you have 3 more. Please go ahead, give those a try on your own, and we'll talk through them together. Okay, we're back. So our GCF here, so 3 is the largest number I can divide all 3 terms by. We have e's in all of them, so e squared is what we'll factor out. We have f in only 2, so since there's no f in our second, we cannot have an f as part of the GCF. So from here, 15 divided by 3 is 5. E squared divided by e squared cancels, and we still have that f squared. 24 divided by 3 is 8. E to the third divided by e squared, so 3 minus 2 is 1, so just e. 30 divided by 3 is 10. 3 minus 2 is 1, and we still have f to the 15th. So notice that because there was not an f in all 3, couldn't factor it. Next one, 15 is our GCF there. We do not have r's in all 3, so can't be a part of the GCF. We do have b's in all 3, so we take b to the 4th there. So here, 15 divided by 15 is 1. We have r to the 4th. 9 minus 4 is 5. 45 divided by 15 is 3. Again, we have r to the 4th. B to the 4th divided by b to the 4th is just 1, so with that cancels. Negative 30 divided by 15 is negative 2. 15 minus 4 is 11. And for the last, 6, 8, and 12, 2 is the largest number. I can factor out of those. We have t to the 8th, 5th, and 12th, so 5 is our lowest exponent, and we've got t in them all, so it's a part of the GCF. Same with p. 9 is our lowest exponent. From there, 6 divided by 2 is 3. 8 minus 3 is, well, 3. 9 minus 9 is 0, so we don't have any p's. 8 divided by 2 is 6. 5 minus 5 is 0 for t, so we don't have t's. 11 minus 9 is 2, so I just have p squared. Negative 12 divided by 2 is negative 6. 12 minus 5 is 7. 16 minus 9, well, that is also 7. And there we go. Okay, so we just did factoring out the GCF with multiple variables. Let's look at what that looks like with polynomials, kind of as we've been seeing them so far. So when we're determining or finding the roots or x-intercepts of a polynomial, algebraically, there are 3 main steps we work through. Number 1, we find the GCF, or factor it out. Number 2, we factor the remaining polynomial, or the remaining quadratic, that will be the remaining polynomial, by thinking about, remember, multiplies to c, adds to b, so that idea comes up again. And then we can find our roots or zeros. So let's start going by step here. So number 1. So let's factor out this GCF. So as I look at my 3 numbers to start, they're all multiples of 4, so I know 4 is a part of my GCF. I look at my variables. They all have x's. 7 is my lowest exponent, so I'm going to be factoring out x to the 7th. So my remaining polynomial, 4 divided by 4 is 1. X to the 9th divided by x squared, again subtract. 9 minus 7 is 2. 28 divided by 4 is 7. 8 minus 7 is just 1, so I just have x. 40 divided by 4 is 10. X to the 7th divided by x to the 7th cancels. So what we have left over now is we have a quadratic where our a value is 1. So since our a value is 1, then we can look for numbers that multiply to c and add to b to help us factor further. So this is review from Unit 2. So we think, what are the 2 numbers that multiply to 10 and add to 7? Multiply to c, add to b. So those numbers in this case would be 5 and 2. So we've factored even more. At this point, now we have 1, 2, 3 factors. So now we need to find the roots or find the zeros by setting the factors equal to 0. So if I take 4x to the 7th, set that equal to 0. If I take x plus 5, set that equal to 0, and x plus 2, now I can solve for x to find my roots or zeros. So these second and third are ones we've seen before. We can get x alone here, subtract 5 to get x equals -5. Subtract 2 here to get x equals -2. This last one may be a little bit more difficult. Well, let's try and get x alone. Divide both sides by 4. So we get x to the 7th equals 0. And let's just think about this. We're looking for what value of x to the power of 7 is going to be equal to 0. Well, what number to the power of 7 is always going to be 0? Well, 0. So our three roots here, and we do have 3, would be -5, -2, and 0. So we do have 3. So we do also have to include that GCF. The GCF is a factor. It's called the greatest common factor. Okay, let's do another. So step 1, factor out the GCF. So 5 is my largest number. 3 is my largest exponent, so 5x to the 3rd will be my GCF. So then what remains? We have x squared there. -10 minus 5 divided by 5 is -2. We have x. -75 divided by 5 is -15. We don't have any x. So at this point, we found the GCF. Step 2, factor the remaining quadratic. So since our a value is 1, we can factor by looking for numbers that multiply to c and add to b. So the two numbers that multiply to -15 and add to -2 would be -5 and +3. And at this point, we can set those factors equal to 0. Set 5x cubed equal to 0. Set x minus 5 equal to 0. Set x plus 3 equal to 0. Solve for x. So we're going to get 0, 5, and -3 when we go ahead and do that. This first one, x equals 0, comes from the same process as that previous problem. Over here, we just added 5 to both sides. And over here, we just subtracted 3 from both sides. So our roots would be -3, 0, and 5. Okay. All right. So we have 4 more problems here. So I'm going to ask you to try those on your own. We'll start with the first 2. Pause the video, give those a try. Okay, we're back. So 6x to the 6th is my GCF, which leaves me with x squared plus 8x minus 20. So then we want to factor that remaining polynomial, that quadratic out, into x plus 10, x minus 2, which then we set those factors equal to 0 to solve for x, to which you get x equals 0, x equals -10, and x equals 2. For the second, 2x to the 9th is my GCF, which leaves me with x squared minus 7x minus 30. We need to then factor out that quadratic into what multiplies to -30, adds to -7, which would be -10 and 3. Set each of those factors equal to 0 and solve for x, which you get x equals 0 there. Add 10 to both sides here to get x equals 10. Subtract 3 from both sides there to get x equals -3. Okay. 2 more. This is your last chance to kind of check out, make sure you've got these correct. So give those a go. Pause it. Okay, we're back. 4x squared is my GCF, which leaves me with x squared minus 4x minus 21. Factor that out. into x minus 7x plus 3, which gives me roots of 0, -3, and 7. For the last, 5x squared is my GCF, which leaves me with x squared minus 7x plus 12. Factor that into x minus 4, x minus 3, which leaves me with roots of 0, 3, and 4 when all is said and done. And that's it.